Hey folks, so today we have the series n squared minus 1 over n to the third plus 1. I'm going to use the test for divergence to see if this series converges or diverges. So here we go. We have the limit as n approaches infinity, and that's a beautiful little thing. If you write as n approaches infinity, you don't have to write the LIM. So there you go. Of n squared minus 1 over n to the third plus 1. I'm going to use algebra here. So this on the top equals n plus 1 times n minus 1 over this equals n plus 1 times n squared minus n plus 1. The plus 1's cancel out. We're left with n minus 1 over n squared minus n plus 1. Now, this right here, we have an invisible 1 here, and this 2 right here, which of course gives us n to the 1/2. And if you put the infinity in, you get infinity, which does not equal 0. Well, you know what that means? That means the series diverges by TFD, test for divergence. For the series 2n factorial over n factorial squared, we're going to use the ratio test because we have factorials. So again, we're going to start with the limit as n approaches infinity of the absolute value of 2 times n plus 1 factorial over n plus 1 factorial squared times the reciprocal of the original, which is n factorial squared. Wow. Squared over 2n factorial, or wow. So the one at the bottom equals n plus 1 times n factorial squared. And this one equals basically 2n plus 2 factorial, which is, I'll write it here, sorry, which is 2n plus 2 times 2n plus 1 times 2n factorial. So guess what happens? It's a beautiful thing. Cancel out. Cancel out. Forget about that one. What's left is what is left, right? 2n plus 2 times, I'm gonna actually change that to 2 times n plus 1 times 2n plus 1. All of that over n plus 1 squared, which, hey, cancel out. There we go. This equals 4n plus 2 over n plus 1. This gives us, invisible coefficient 1. In the 4, we have 4 over 1, which is 4, which is 4, which is way bigger than 1, which is a good thing, because this one, that means this one diverges by ratio test. Alright, for this one right here, we have the series n squared plus 1 over 2n squared plus 1, all of it to the power of n. For this one, we're going to use the root test to determine the convergence or the divergence. So here we go. As n approaches infinity, that is the limit, we're going to have, it's a big thing, nth root of the absolute value of our function, which is, series, which is n squared plus 1 over 2n squared plus 1 to the power of n. It's a big ass thing. It's going to be small. Yeah, so this equals n squared plus 1 and 2n squared plus 1, all of that to the power of n over n over n, which equals 1. It's a beautiful thing. So basically we have n squared plus 1 over 2n squared plus 1. You know, 1, you just don't write the power 1, so, and it's a beautiful thing. Look at that. Invisible 1 into 2, not equals this one. Okay, 1/2, which is smaller than 1, which is a good thing, because it means this one converges by root test.